Okay, so good evening, guys. So I'm going to discuss to you now the principles of ultrasonography, specifically on the physics of sound waves, since this is the major reason why there is the ability of ultrasonography to demonstrate images on the display monitor because of the presence of sound waves. Okay, so first and foremost, when we talk about sound waves, it actually are the waves that travels in a medium, transmitted through a medium, and the waves are somewhat similar to other waves that you have already heard, especially very much similar to yung tinatawag nating electromagnetic energy waves. Okay, so electromagnetic energy waves are the type of waves that are being used in diagnostic X-ray. Okay, since X-ray is actually under the group of electromagnetic radiation, but they are considered to be ionizing radiation in origin, whereas ultrasonography or the sound waves are falling under the category non-ionizing radiation. Okay, so basically that's their difference, the effect of the waves to the body, and also the ability to image bodily organs, no, depending on the type of radiation that they use. Since we are talking about ultrasound, so we will concentrate more on the physics of sound waves. Although, as I mentioned during my introduction, no, the physics of sound waves is almost similar to that of the physics of electromagnetic waves. Parehas lang siya ng parameters. Okay, it has also frequencies, it has also velocity. Okay, and it is also completing cycles, but the very difference of it is, of course, its application. Okay, so you all know for a fact that the description of waves, no, for any type of energy is actually a vibration of particles back and forth, papunta, pabalik, nagbanggaan from one molecule to another. Okay, so if there is a wave here, okay, normally the vibration is caused by the interaction of the wave to the different molecules in the medium. Most probably also, please remember that the difference between sound waves and electromagnetic waves can travel in a vacuum or can be produced in a vacuum, while sound waves should have a medium. So when we talk about medium, ang pinag-uusapan natin dito is the object, no, where the sound waves should travel. Okay, anything that has molecules are considered to be medium. So they are classified accordingly. They are classified as either solid, liquid, or gas. Now the interaction of sound waves with solid, liquid, and gas differ. Sound waves usually travel faster in solids and very slow on gas. Okay? And normally, the images that they will be producing will depend on the interaction of the sound wave with the medium. Say for example, as we have mentioned already in introduction to ultrasonography, meron tayong tinatawag na echogenicity, di ba? Echogenicity is actually the term that describes the images in the display monitor. So, it is actually characterized by the brightness of the dots that are shown or demonstrated in the display. So, the brighter the dots are, okay, they are called more echogenic. Okay, if there are no dots or brightness dot, it means that they are anechoic. There is no echo produced. Okay, kasi si ultrasound po natin, ang pinaka-basic, no, tandaan ninyo, ang pinaka-basic niyang principle is the principle of reflection and echo production. So, I am sure also, alam nyo naman kung anong ibig sabihin ng echo. Okay, yun yung bumalik. Okay, so that is particularly the reason why ultrasound can image. Okay, so of course, we need the equipment that will produce the sound waves, and that is actually your transducer. So if you have already watched, no, the fundamental physics that is uploaded, no, in your LMS, I hope you did, no, so you will understand the role of the transducer in the generation of waves and also its reflection. So the transducer class, as mentioned there, contains the piezoelectric crystal, of which the piezoelectric crystal is the one that produces your sound waves when electricity is applied. So, nakalagay dyan, when electricity is applied, the electrical energy is converted into mechanical sound energy. So, lalabas yung sound wave na sinasabi natin. Once na nakalabas siya sa transducer, it will now interact to your bodily tissues. And the composition of your bodily tissues, no, is usually described as either solid, liquid, and gas. Okay, so here I have a diagram of what a sound wave looks like, although I know that you are already familiar with how it looks. Okay, so in the square that is presented in this diagram in letter A, this one represents one complete full cycle. Okay, letter B is the representation of the molecules that can be present in the body or in the medium with differing distances from each other. So as you can see, in this particular region, no, the molecules are almost farther away from each other. This one, they are usually closer, farther din yung susunod, then closer, and then farther. The position of the molecules will directly affect the travel and velocity of the sound waves. That is why in the medium, there are what we call pressure fluctuations. Okay, so what are pressure fluctuations? So, ibig sabihin ng pressure fluctuations, class, is the differences of pressure in different components of the medium. The nearer the molecules are to each other, the pressure fluctuation is usually higher, and the further the molecules are in a medium is to each other, the pressure fluctuation is usually lower, higher. So these are described as zones of pressure. Okay, so anong klase ng zone kaya ang ibig sabihin pag mas malalayo at mas malalapit? Yung mas malalayo, they are usually called rarefaction. Okay, and then yung mas malalapit, they are usually called compression. Okay, so these are compression fluctuations in pressure, rarefaction fluctuations in pressure. And then below is actually the sample diagram of how the wave will vibrate, the direction of the wave. So here in the sample letter C, the direction of the wave is longitudinal. Ibig sabihin, it usually is parallel to the direction of the sound beam. So if the direction of the sound beam is paganyan, and then the travel of the sound wave is paganyan, ang tawag dito sa klase ng wave na mapoproduce nila ay longitudinal waves. Okay? Because it is parallel. Okay? The direction of the beam is parallel to the vibration of your sound waves. Okay? While when the direction is perpendicular, like for example, instead na diretso siya ng ganyan, paganyan-ganyan siya, pataas pababa siya, that is called transverse wave. Okay? So it will produce transverse waves. And these are both useful in ultrasonography. So the direction of the wave is actually dictated by how much energy the wave contains when it travels through a medium. Okay, one also of the things that we should consider is acoustic variables. Okay, so when we say acoustic variables, these are the quantities that vary in sound wave, or actually this one controls the direction of the sound wave plus the reflection ability of the medium. Okay, so when we say acoustic variables, these are actually the characteristic of the medium that is involved in ultrasonography. So sabi ko kanina, tandaan ninyo, meron tayong medium natin is meron tayong solid, okay? Then we also have liquid and also gas. Okay. So as I also mentioned earlier, okay, they have different components of molecules. Like for example, the molecules of solid is usually closer to each other. Si liquid medyo malayo ng konti. Okay? Pagdating naman sa gas, magkakalayo na talaga yan. Kaya, if the sound waves travel here, it usually travels faster. Kasi malalapit yung mga molecules na pwede niyang mabangga. Whereas this one, medyo malayo, so medyo matagal ang travel niya. And then, mas lalo naman ito. Okay. One characteristic of ultrasound class is it is usually gas blind. Ibig sabihin, if an organ that you want to image is surrounded by gases, it does not have the ability to reflect the sound wave. So there will be no echo produced. There will also be a hazy appearance, okay, of the image, which will not render visibility of the organ surrounded by the gas because of the properties of a gas. Kaya tinatawag na gas blind ang ultrasound. Okay, whereas dito naman sa liquid, sound waves just travel through it. It does not reflect. Okay? So, ito totally no echoes are generated, which renders the image as described anechoic. Okay? Ito, meron siyang konting reflection, kaya lang very faint. Konti lang yung echoes na napoproduce nito kasi very faint lang. So, ang nangyayari, nagkakaroon ng echogenicity pero masyado siyang mababa. So, ang tendency nito, yung hyper-echogenicity niya will actually render the organ not to be able to be visualized. Whereas, solid components of the medium in our body usually have, for soft tissue organs, usually have good echogenicity. That's why they are very particularly well demonstrated using ultrasonography. Now, going back to what I was saying about acoustic variables, there are three characteristics in the medium that varies from one area to another. Okay, so the density of the medium, the pressure in the medium, which is I also already said that is dictated by the molecular component, and the particle vibration. Okay, so when we talk of the density, so of course, relating it to solid, denser ang solid medium natin kaysa sa liquid and gas. Okay, sa pressure, I also mentioned about rarefaction and compression. So this one usually is dictated by how closer and how solid the foundation of the molecules that are present in the organ of interest. And then the particle vibration, this usually has something to do with the cycles of increase and decrease because of the presence also of your pressure fluctuation na sinasabi ko kanina. Okay, so it will also affect, Kasi, remember I said, pag mas malalayo yung molecules natin, mas matagal ang particle vibration kasi mas malayo ang mararating niya bago siya mag-vibrate. Whereas, kapag malalapit siya, mas mabilis siyang mag-vibrate kasi magkakatabi lang siya. So, yun ang ibig sabihin ng particle vibration. Okay, now, the components that I was describing about pressure fluctuations actually is your compression and the rarefaction. So, this is usually the high pressure region kasi ito yung malalapit where the molecular components is more dense, while the rarefaction is the low pressure region while the molecular density is low. So, for compressions, the molecules would usually look like this. Okay, very near to each other ang positioning ng molecules mo, whereas for rarefaction, medyo magkakalayo. So, this one usually has high molecular density, which will also indicate a high pressure region, whereas this one has low molecular density, which will also indicate a low pressure region. Okay, remember that zones of compression and refraction alternate as sound is transmitted to the medium because the organs of the body composes usually of different types of medium. There are organs that are complex na sinasabi natin, which can be composed of different types. It has solid, it has liquid, or it has gas. Okay, most especially when we are talking about ultrasound because this is in your abdomen. And the abdominal organs usually are very complex in nature. Okay? And then, always remember, as I said a while ago, sounds cannot travel in a vacuum. So, it becomes useless when it's vacuumized. Hindi siya kagaya sa X-ray na para makapag-generate ka ng electron cloud in order to produce the X-ray or the radiation itself, the ionizing radiation, it should be in a vacuumized or sealed tube. Okay? So, yon. And then, as I also mentioned a while ago, longitudinal waves travels. These are the sound traveling along the parallel direction of the wave, whereas the other one is what you call the transverse wave, which is the type of sound that travels perpendicular, okay, to the direction of the wave. So, those are the things that you should remember when we describe the traveling of your wave. Okay, to better understand the characteristic of the sound wave, let us also remember the different parameters of the wave. So again, going back to the different types of sound waves, it depends on the classification of their frequencies, right? So before we discussed that we have the audible sound, which is the sound that can be heard. We have the infrasound, which is the sound that is very, very low that cannot be comprehended by the human ear. And we have the ultrasound, which is the sound that has a very high energy that usually is also not being comprehended by the human hearing. So among all of this, what we are now using, or what is used by us every day, is the audible sound. Okay, but in whatever type of sound waves we are referring to, they always will have the same parameters. Hindi magbabago yung parameters ng audible, infra, at saka ultra. As a matter of fact, the parameters of the wave dictates the type of sound waves that is present. Okay, so let's take a check on the different parameters of the wave. So you have here the frequency, you have period, you have wavelength, you have the speed or velocity, you have the amplitude, and you have intensity. Okay, before I discuss them one by one, please remember that the waves are being affected by the type of medium, okay, where it travels. Okay, so the frequency, period, wavelength, speed, amplitude, and intensity will greatly be affected by the type of medium where the sound waves will travel. Let's talk about frequency. So what is frequency, class? So frequency is actually the number of times the cycle is repeated per unit of time. Okay, so yung unit of time natin, sometimes it's easier kasi for us to relate it to our very common time, which is the second, the minute, and the hour. Okay, but remember that sound waves travel very fast. So usually it is being described in second. But for ultrasound, kasi masyado nang maliliit yung waves ng ultrasound, we usually use the description of the wavelength of ultrasonography is millimeter for ultra, UTZ. But the description for audible of the wavelength is centimeter. Therefore, when we talk about frequency, the description here is microsecond. Okay, so the time it takes for one complete cycle is usually described as per second, and then if you want it to be in ultrasonography, so you have to convert the second to microsecond. Okay, so we've been discussing the frequency actually because the frequency dictates also the kind of sound waves that is present. So sabi natin, if it is audible sound, that is usually 15 hertz, okay, to 20,000 hertz or 2 kilohertz. Whereas kapag sinabi mong ultrasound, it is beyond 20,000 kilohertz. Ultrasound that is useful in ultrasonography, we said that's 120 megahertz, very far from the hertz. Well, whereas infrasound is usually less than that, okay? Okay, less than the 15 hertz that describes the audible sound. Okay, so frequency is usually represented by the unit hertz, okay, or the symbol capital H and small z. 1 hertz is equal to 1 cycle per second. So if this is your reference, the wave is from here, it travels up, it travels down. When it reaches that particular area, it is usually already equal, and then it goes down and then goes up, and then when it reaches the same platform where it started, that now completes one cycle. Okay, so that is frequency. Okay, now let's take a look at the diagram here, the differences of the pressure in the sound wave. Okay, so this one, as you can see, is measured by second. This one is measured by microsecond. Okay, so this one means that it is faster than this one. Okay, so although they are both in the ranges already of ultrasound. Next parameter, we have period. Period naman, on the other hand, class, is the time it takes for one cycle to occur. Okay, yun na yung described as second or microsecond. Okay, then we have the wavelength. The wavelength is the length of space that one cycle takes. So when we say length of space, kung dito siya nag-start, okay, for example, this one is one wave until there. So the length is measured from the beginning until it completes one cycle. So let's say, for example, this is 0.20 millimeters. And then another wave, medyo malaki. Okay, so mas malayo yung kanyang distance, so that the distance it travels, let's say for example this is 0.70 millimeters, so it's farther from the first one. Okay, that is what is meant by wavelength, the distance, no, that will be traveled by the sound in order to complete one cycle. And as you can see here in the table, no, these are the frequencies of useful diagnostic ultrasound ranges, okay, with their equivalent periods and wavelength. So as you have seen, no, as the frequency increases, as you can see, the frequency here increases. This is the frequency of transducer that is being used by diagnostic ultrasound. So you have 2, 3.5, 5.0, 7.5, 10, and 15. Pinaka-common na ginagamit is 3.5 at saka 7.5 for regular ultrasound procedures, while 2 is usually used for superficial organs and for big patients or yung medyo hyperstenic in build or yung matataba, and 7.5 is usually used for deep-seated organs and for thinner patients. Okay, ganun din si 10 at saka 15.0. The frequency also determines what organs can be demonstrated using the transducers. Okay, now as you can see, as I mentioned earlier, while the frequency increases, the period decreases. Okay, meaning to say, the time it takes to complete one cycle is usually faster when the frequency is higher. So they are what you call indirectly proportional. Okay, whereas the relationship between the frequency and wavelength, on the other hand, measured in millimeters, no, is usually also decreasing. While the frequency is increasing, the wavelength is also decreasing. Ibig sabihin, mas lumiliit yung distance na tinatravel niya kapag mas mataas ang frequency niya. Dahil mas maliit yung distance na tinatravel niya, mas mabilis din siya. So again, the relationship of frequency to that of the wavelength is indirectly proportional. Whereas, the relationship between period and wavelength, as period decreases, wavelength also decreases. So they are directly proportional. Tong dalawang to, directly ito, indirectly yan, at saka yon, indirectly. Okay, next parameter we have the propagation speed. Speed or velocity. No, we commonly cross the encounter speed as velocity in other physics discussions. They are actually the same. This is how fast, no, it usually travels. So propagation is speed because we are talking about the propagation of sound waves here, or the transmittal of sound waves from the piezoelectric crystal until it transmits to the body. Okay, propagation speed with which a wave moves through a medium is usually the speed at which the completed travel of the sound waves, no, will be considered in imaging. So that's how fast it travels. Okay, and usually wavelength depends on frequency and the propagation speed. So, ibig sabihin, class, yung distance na tina-travel ng sound waves is dependent on the frequency, that's your energy, or the time it takes for one complete cycle to occur, and the speed, or how fast it is. So, the relationship between the three is that wavelength is equal to propagation speed divided by the frequency, as it's represented by this formula. Okay, lambda represents wavelength in millimeters for ultrasonography. We measure wavelength in millimeters, and then usually the speed, no, is measured in microseconds, millimeter per microsecond. Ano yung C? This one represents the word constant because ultrasound speed for soft tissue organ is constant. Ibig sabihin, pare-parehas, which is actually equivalent to 1,400 540 meters per second. So you convert that into millimeters per microsecond over the frequency. So kung ilang frequency ang ginamit mo. So how do you compute for the wavelength? First, you use, okay, this one because this is the constant speed. And then the frequency varies kung 2, 3.5, 5.75, ganyan. So for example, you use 3.5. So to determine the wavelength, no, of a 3.5 megahertz transducer to the transmission of the sound waves, you have to divide the constant speed of 1540, okay, divided by 3.5 hertz. And the resulting product here will be equivalent to the wavelength that it travels. Okay, so using the formula as in a complete example, no? So, if you convert 1540 meters per second, this will become 1.54 millimeters per microsecond. So, ito siya. This is the constant speed of sound waves in soft tissues. Constant class, hindi nagbabago, always given. Okay, and for example, you use 5 megahertz transducer. Okay, you divide that. So, anong magiging equivalent niya? This is 0.31 millimeters. Okay, going back, let's take a look back at the table. Okay, so you have here your 5.0. Okay, so pag sinabi nating 5.0, okay, that is the frequency used, and then your wavelength is 0.31. Now let's talk about the properties of sound waves. Okay, so what are the properties of sound waves used in ultrasonography? First, they are actually pressure disturbances.